We're going to go ahead and solve now 3 tangent squared of x minus 1 equals 0. And before we just jump into this guy, let's just make sure that we don't lose the meaning of what we're doing and lose what we learned in Algebra 1. Like, say if I gave you a quadratic as simple as this, and then, it was y equals, x squared plus 4, and then I said, oh, now set the y equal to 0, right? So I just made 0, or I made y 0. What is it that we're doing when we set y equal to 0? Well, we're finding the x-intercepts, right? When y is 0, we're finding the x-intercepts. So really, if you look at this problem right here, that's what we're doing. And from all the problems that we've been doing in all these examples, we've been finding the x-intercepts. So if you were to graph this right now, even before we start on the problem, and then use the trace feature or the 0 feature on the graphing utility, and you want to find the x-intercept, really that's all we're doing right now. We're just finding where does 3 tangent squared of x minus 1, when does it equal 0? And when the graph equals 0, that's just implying where the graph crosses the x-axis. So just want to make sure that we're not losing the what are we doing and why are we doing it, other than just the just going through the motions of just solving for it. But it has a meaning behind it, okay? So let's go ahead and solve for tangents. Let's first add 1 and divide by 3. So I'll have tangent squared of x equals 1/3. So I did 2 moves right there. I added 1, and then I divided both sides by 3. If I want to get rid of the square root, I'm going to introduce a square root. And what have I taught you? When you are the one who introduced the square root, plus or minus. That's right, little Billy. So you need to put a plus or minus right here. So it'll be tangents of x equals plus or minus radical 1/3, which is the same thing as plus or minus 1 over radical 3. Or if you don't want the radical in the denominator, plus or minus radical 3 over 3. Okay? So just make sure if you are the one who introduces the radical, you're always going to put plus or minus. Now, another note right now before we just start diving into this, and that is the tangent graph, if you remember, has a period of pi. So when we are trying to find what x values have plus or minus 1 over radical 3, we are only looking from 0 to pi, okay? That's very important there. Only look from 0 to pi because we're only looking in one rotation, and then we're going to tack on the other ones from there. So let's check this out here. If you look at a unit circle here, I want plus or minus 1 over radical 3. So I know that our first one, just 1 over radical 3, it's going to be at pi over 6. So if you look right here, our first coordinate point right here, that's the coordinate point radical 3 over 2, 1/2. So if I do y over x, 1/2 over radical 3 over 2, you would get 1 over radical 3, which is pi over 6. So that's going to be our first answer. X equals pi over 6. And we have another one. When you have 1 over radical 3, you just kind of go on the opposite side over here. And that's going to be at 5 pi over 6. Okay? So 5 pi over 6. Now, and this is why that is important to say that it only has a period of pi, meaning all I'm going to add is just pi n, where n is within the integers. Because if I'm at pi over 6, and if I add pi to that, well, won't I be just right here then? Right? So that's going to be at 7 pi over 6. So that's kind of where that comes from right here, is that all I got to add is right here, and now I'm going to be at one of my plus or minus 1 over radical 3. And then same thing right here. If I'm at 5 pi over 6, if I add pi, okay, you're going to be at 11 pi over 6. So this is why it's important to know what the period is because we have to use that information now. So it's going to be pi n, where n is within the integers. Okay, so those would be our two final answers right there.